Hey guys, today we're going to talk about how to apply what we know or what we've learned about scatterplots, specifically the correlation coefficient and the linear regression model or linear equation. So first let's talk about why we even find the correlation coefficient. So if two things are correlated, that just means they're related. So now that you all understand how to find the correlation coefficient, if you don't remember, you can go back and watch that video again. Let's talk about how to interpret that. So I want you to think about a number line when you think about the correlation coefficient. Okay, and we're going to draw a number line with 0 in the middle, -1, and +1. So when we talk about correlation coefficients, those coefficients, or the strength of a relationship and the description of the relationship, fall somewhere on here, on this number line. So let's talk about how to interpret this. The next thing I want you to do is draw a -0.5 here and a +0.5 here. There's a reason for this. So anything that falls, and remember, you can see the examples of the correlation coefficients for number 1 below, -0.82, 0.23. Those are what our correlation coefficients look like. Well, if a number is above 0.5 or above, we say that that is a strong positive correlation or relationship. Those two variables or two things have a strong positive relationship. Similarly, if the number is between -0.5 and -1, we say those have a strong negative correlation, or a strong negative relationship. Let me write that again, negative. So if those are strong positives or strong negatives, let's talk about what the other numbers mean. And I'm actually going to use yellow here. So if it's below or between -0.5, like if it's -0.4, or below 0.5, those are said to have weak correlations or weak relationships. So if it's on the negative side, you would say that's a weak negative relationship. Sorry about my pen, guys. A weak negative relationship. And if it's on the positive side of 0, you would say that's a weak positive relationship. And I won't go into detail about what the positive and negative mean. Just bottom line, you want to be able to decide if something is strong or weak and negative or positive. So let's take a look at some of these examples. Excuse me, look at number 1. And if you will, jot these numbers down because you want a good resource to look back at. So number 1 says, describe each correlation given the correlation coefficients. So look at A. -0.82. So if I were going to put this on a number line, it's going to be between -0.5 and -1, actually a little bit closer there. So I would say that is a strong negative relationship or a strong negative correlation. Now let's take a look at, and I'm going to erase that. That's okay. B, which is 0.23. So 0.23 on the number line is going to be between 0 and 0.5 on the positive side. So it's going to be about, it's going to be about right there. So that's going to be a weak positive. Weak because it's between 0 and 0.5, and positive because it's on the positive side of the number line. Look at C. For C, we have positive 0.6783. So 0.6783 is going to be a little bit above 0.5. So that correlation is going to be a strong, and it's on the positive side. So a strong positive, and you got it. The negative positive part is easy. And if it's 0.5 or above, it's strong. Or on the negative side, 0.5 or to the left. Look at D, negative 0.9922. That's going to be almost at the -1. So that is definitely strong, and it's on the negative side. So we say these, whatever this correlation coefficient represents, has a strong negative relationship. And lastly, negative 0.378. That's going to be oh wait, it was negative. Oop, I was on the wrong side. Negative 3.78 is going to be somewhere around here. So that's going to be considered a weak, and it's on the negative side. So a weak negative correlation relationship between those two things. So that's why we learned the correlation coefficient. It describes the relationship. Now let's take it a step farther, and let's actually look at a specific example. Let's take our understanding a little bit deeper. So I give you a table. It says the table gives the number of hours spent studying for a math exam and the final exam grade. So we're going to use Desmos, our graphing calculator, to find the correlation coefficient and to describe the correlation. And then we're also going to use our linear regression model and do some things with that. So first, let's graph our table. So I'm going to add a table. My first entry is 384. Next is 277, 592, 170. Then I've got 0, 60, and I have 490 and 375. Now we want to, let me double check. I always like to double check and make sure I've put everything in properly, because sometimes we can overlook things. Okay, yep, that looks good. Now I want to add an expression. So I want to do y1 is approximately, I think that's what that stands for, mx1, 1 plus b. So now let me get my information. And for this, I do want us to round to the nearest whole number for our equation, our linear regression model. So first, remember, we want the correlation coefficient, which is the R, so 0.9556, 0.9556. And while I have my calculator up, I'm going to go ahead and write my equation, or my linear regression. So it's going to be y equals 6x plus 62. Y equals 6x plus 62. Now let's get to the reason why we did this. So in this table, the two variables, the two things that are being compared are the number of hours studied and the grade. My correlation coefficient is 0.9556. So based on what we just learned, 0.9556 is like right here. It's almost at 1. So that is a strong positive correlation. So what that means, there's a strong relationship between the number of hours studied and the grade. Positive means they travel together. So as the number of grades go up, the number of hours you study go up, your grade should go up. That's how we use that correlation coefficient to describe a relationship. There's a strong positive one. Now let's take a look at our linear regression model. Part D says describe the slope. Well, We know the slope is 6. What two things are we comparing, guys? Here's how you describe your slope. Remember, this is x. The top is x, the bottom is y. Don't you remember that when we find slope, it's rise over run? What is my rise here? It's my grade. What is my run or my x? The number of hours studied. So watch this. How would I describe the slope? It's positive. So I would say your grade increases 6 points each hour you study. And we've actually done this before, but now we're using it in the context of scatter plots. So we use that to describe our slope, rise over run, and just use the relationship that they've given us here. Now let's continue. Look at E. E says, what grade could someone who studied 2.5 hours expect to get? Well, didn't we say hours was the same thing as x? So watch this. This is another reason that we find a linear regression model. Y equals 6x plus 62. Y equals 6. How many hours do we want to study? 2.5 plus 62. So I'm going to use my calculator just for accuracy. So I'm going to say 6 times 2.5 plus 62 is 77. So a person who studies 2.5 hours can expect to get a 77 on their test. Now let's look at one more way we could use that linear regression model. How long would you need to study to get a grade of 100? Well, what did we say? Well, it didn't say grade, but we know if we get a 100, that's a grade. Grade is the y. So watch this. Y equals 6x plus 62. I want to get a 100, so I want to see how long I have to study. So now I'm going to solve for x. Now you can do that by hand. I'll go ahead and do it by hand, but remember we've also learned how to do it in the calculator. So I'm going to subtract 62 from both sides. Negative 52 equals 6x. Divide both sides by 6. I'm going to go ahead and use that to 52 divided by, oops, gotta clear out. 52 divided by 6. Now something's not making sense to me here. Oh, I forgot and I made a mistake. Okay. So if I want to see how long it would take to get a 100, we said grade is the y. So I'm going to put 100 in place of y and solve for x. Now, we can do this on the calculator, but just for this one, I want to go by hand. I'm going to subtract 62 from both sides. When I do that, I get 30, let's see, I'm sorry about that, 48. 38 equals 6x. I'm going to divide both sides by 6. So 38 divided by, again, I need to clear up my thing. Okay. So if I want to see how long I need to study to get a 100, this time I'm going to substitute the 100 in for y, because we said y is the grade. Remember, we identified that earlier. So 100 equals 6x plus 62. So I'm going to plug that into my calculator. 100 equals 6x plus 62. And when I do that, I find my solution to be 6.333333, which is a 6.3 repeating is about, what is 1/3 of an hour? You can, of course, write 6.3 repeating hours, or you could say 6 hours and 20 minutes. Either one of those would be correct. Now let's take a look at what would happen if we have this type of situation. So in this table, it shows the number of cases of foodborne botulism in the U.S. between the years 2001, 2005. And by the way, botulism is like food poisoning. All right, so the first thing we want to do is get our information from our table. And we're going to use our Desmos to do that, our graphic calculator. But remember, when we have years, we've got to set some things up, change it a little bit. So we're going to say the year 2001 is 0. 2002 is 1 year after 2001. 2003 is 2 years after 2001. 2004 is 3 years after 2001. And 2005 is 4 years. So those are the numbers we're going to input for our X, and our Y will be the number of cases. So let's go ahead and do that. I want to add a table, and I will have 1, 39. Oh, I'm sorry, 0, 39. 1, 28 will be my next entry. 2, 20. Next will be 3, 16. And the last year is 4, or the last entry is 4, 18. And now I'm going to write my expression. So I have Y1, little squiggly mark, MX1 plus B. All right, so let's jot down our information. So my R, or my correlation coefficient, is negative point, let me get back to my thing here, negative 0.904. And again, I'm going to round to the nearest whole number. Just for this example, remember, if it's on a test, you just use your examples. Use your answer choices to help you. But for this, I'm going to use whole numbers. So Y equals negative 5x plus 35. So now let's go through and actually use this information. So how would I describe the correlation? Well, first of all, I can clearly see it's negative. And 0.9 is, negative 0.9 is right about here. It's almost at -1. So that is definitely a strong negative correlation. And that makes sense because as the years increase, the number of cases decrease. That's what a negative relationship means. So a strong negative relationship or correlation. Now let's take a look at our equation or linear regression model. We're going to use that to describe the slope. Well, we know the slope is -5, right? But what does that mean? Once again, we know slope is the y's over the x's, rise over run. Y in this case is the number of cases, and x is the year. So what does the slope mean? -5 means it goes down. So the number of cases decreases 5 each, what's on the bottom? Year. Rise over run. Decreases 5 cases each year. Now we're actually going to use that equation to make some predictions. That's the entire reason that we write equations or a linear regression model. So let's write that equation. Y equals -5x plus 35. So E says, how many cases will there be in 2007? Now I'm not going to plug 2007 in, right? See, my X is years. but what am I going to plug in? Well, 2007 is 6 years after 2001. And you got, a couple of ways. You could subtract that. 2007 minus 2001 is 6. Or you could just count up. That's another way. And I always like to use my calculator to make sure. It looks like it's going to be 5. But again, I like to make sure. So, -5 times 6 plus 35. Yep, it's going to be 5. So, how many cases will there be in 2007? 5 cases. That's the prediction based on our linear regression model. What year were there 85 cases? So let's go back to that prediction model. Y equals -5x plus 35. 85 cases, that's what they give us. We said cases was represented by Y. So now I'm going to say 85 equals -5x plus 35. You are welcome to solve this by hand, or you can use your calculator. I can easily see this one, so I'm going to go ahead and do it by hand. So I'm going to subtract 35 from both sides to get 50 equals -5x. Divide both sides by -5. This is weird. X equals -10. But here's the deal. What does that mean? If 0 is 2001 is my first year, and my year that I come up with is -10, what does that mean? Well, guys, all that means is that 10 years ago, you see that? 2001 minus 10 is going to be 1991. That means in the year 1991, there were 85 cases. So this, guys, is how you determine the correlation using the correlation coefficient. You use the linear regression model to describe the slope and make predictions.